high school algebra course are probably to the point where you're either about to already have learned how to multiply a plus b squared. Well, how are we going to do this? Well, this is just the a plus b in their quantity squared. A plus b represents just some kind of a number. So you can say that this equals a plus b times a plus b because it's that whole quantity squared. So how are we going to do this? Well, the way I was taught is we're going to FOIL this. So that means that anytime that we have something like a plus b times a plus b, doesn't necessarily have to be the same, but anytime that you have something like in this form, then we're going to multiply the first outside, inside, last. So A is first, then you go here to get the outside part, then the b times a is inside, then b times b is our L. So in that case, this would end up being a squared for the first one, and then we're going to add what we get for the outside part. So plus AB, then the inside part is BA, and then the last is B squared. But notice that AB and BA are equal, so this is just going to be A squared plus 2AB plus B squared. So, okay, that's how this works, but if we want to visualize this, then draw out a square, for example, and let's say that it has side length a plus b, okay? So let's say that this part right here is your A part, that's your B, and this, let's say this is going to be A and B. So if we do the area of each individual piece, then we're going to get A squared here, then that's going to be an AB piece, this is AB, this is B squared. And notice how this whole area is going to be represented by the quantity a plus b squared, because the area of a square equals the side length squared, and our side length is a plus b in this case, so that's going to be squared equals a plus b times a plus b, and just adding up the individual areas to make the whole area to represent this quantity. We have a squared plus ab plus ab plus b squared equals a squared plus 2ab plus b squared. And yeah, okay, so this is how you would do this. This is a unique case of a binomial expansion, which I'll do another video on, where we have coefficients of 1, 2, and 1, which is going to come in handy when we talk about the fact that if we're going to change our exponent here to something other than 2, like to n, then the exponents, or the coefficients, as we find out, are gonna correspond to the different rows on Pascal's triangle. But I'll do another video about that so you can see how that works. So come back and watch the next one where Joe shows you how